Hello everyone, welcome to a new lecture. In this video we are going to talk about magma. The reason we talk about magma is when magma cools down, it creates igneous rocks. So the parent rock or the parent material that creates igneous rocks is magma, and it's very important to understand what is magma. So what is magma? Well, magma is a completely or partially molten rock. If you have rock underneath or in the subsurface, and by any condition, either by heat, pressure, or sometimes any other factor, you get a molten rock or you melt this rock, it becomes a magma. Therefore, magma is completely or partially molten rock. Where do we get magma? Well, we get magma most of the time from Earth's uppermost mantle. The greatest quantities are produced at divergent, convergent plate boundaries or in hotspots. We get magmas in divergent plate boundaries because two plates are separating, therefore causing a decompression and making the mantle to rise. In convergent plate boundaries, you have a plate going underneath another plate, and in the way you get rock to melt and rise to the surface. And in hotspots, you have magma rising from the mantle. So mostly in these areas, you get magma, or they originate mostly in these areas. So what creates magma, or how does nature create magma? Well, nature creates magma in three different ways. The first one, as a result of a decrease in pressure without an increase in temperature, that can produce decompression melting. So decompression melting can actually create magma. And the way this works, imagine you are in a divergent boundary where two plates are getting away from each other. This causes the crust to thin out. Since two plates are getting away from each other, the space in between causes a decompression, and this decompression causes a decrease in pressure, therefore causing the mantle or the rocks beneath to rise above and melt in the way. So as a result, in decrease in pressure due to decrease in loads over top, we can create magma through decompression melting. The other way that nature creates magma is through introduction of water or sometimes impurities that can lower the melting temperature of hot mantle rocks sufficiently to generate magma. The third way that nature creates magma is through heating of crustal rocks above their melting temperature, producing magma. Sometimes you have magma deep inside Earth that rises, and these magmas contain a lot of heat. When this heat is transferred to the rocks surrounding, it causes the rocks to melt and to rise up to the surface. We have two end products of magma. Since igneous rocks come from magma, we have intrusive or plutonic igneous rocks where the magma crystallizes at depth in the earth. So if you have magma that crystallizes inside earth without coming out on the surface, it is called, or the end result of this magma that cools down, it is called an intrusive or plutonic igneous rock. But if your magma comes out, or if the magma comes out and cools down on the surface, it creates volcanic or extrusive igneous rocks. So intrusive, the magma cools down inside Earth. Volcanic or extrusive, the magma cools down on the surface of the Earth. There is a little thing that you should keep in mind, and that is, if you have molten rock inside Earth, it is called magma. As long as the molten rock is inside Earth, it is called magma. As soon as your molten rock comes out to the surface, it is called lava. So lava is molten rock that is on the surface. If you have a volcano and it erupts, all the molten rock that comes out, it is called lava, not magma. But the molten rock that you have inside Earth is magma. By now, you should ask yourself the question, why does magma, or why do magmas rise to the surface? Well, the physics of this is very, very simple. You know magma is liquid, and the rocks that surround magma is solid. Solid materials are denser than liquid materials. Therefore, the liquid material will rise to the top, and the solid material will stay in the bottom. That's why magma rises to the top. Just like if you have a piece of wood and you sink it into a cup of water, the wood will rise to the top. Just like that, magma is less dense than the solid rocks around it. That's why it will rise to the top. So what does most magma consist of? Well, most magmas consist of three components. It consists of a liquid component, a solid component, and a gaseous component. Your liquid component is mostly mobile ions of the 8 most common elements found in Earth's crust. So the elements or the ions that you have in Earth's crust are an essential component of the liquid part of magma. So silicon, oxygen, along with aluminum, potassium, calcium, sodium, iron, and magnesium. These are the most common elements found in Earth's crust, and they are the ions that you can find in magma. Sometimes you have hydrogen and oxygen too. So what is the solid component composed of? Well, you have crystals of silicate minerals, but your gaseous component of magma is mostly water vapor, carbon dioxide, or sulfur dioxide. So most of the time you have H2O in the form of water vapor, you have CO2, or you have SO2, sulfur dioxide. Based on these components, you get different types of magmas. So basically you get 4 types. You get ultramafic, you get mafic or basaltic, you get intermediate or andesitic magmas, and you get felsic or rhyolitic magmas. So the elements that we mentioned, either silicon, aluminum, iron, calcium, magnesium, potassium, sodium, hydrogen, or oxygen, based on these elements and what type of gaseous component you have, most of the time what is important is your sulfur dioxide. The percentage of the sulfur dioxide that you have in the magma determines either you have ultramafic or felsic magma. So ultramafic contains 35% to 45% sulfur dioxide, but it has very high percentage of iron, magnesium, calcium, and low percentage of potassium and sodium. Your mafic or basaltic contains around 45% to 55% sulfur dioxide, and it has high percentage of iron, magnesium, calcium, but low percentage of sodium and potassium. Your intermediate magma or your intermediate igneous rock, sometimes called andesitic igneous rock, contains 55% to 65% sulfur dioxide, and they are intermediate in iron, magnesium, calcium, sodium, and potassium. But your felsic or rhyolitic magma or igneous rock contains a very high percentage of sulfur dioxide. It contains 65 to 75% sulfur dioxide, Si2, but it is low in Fe, Mg, and calcium, and high in sodium and potassium, or potassium and sodium. So based on the elements that you have in Earth's crust and based on sulfur dioxide, the percentage of sulfur dioxide, you get 4 different types of magma. You get ultramafic, you get mafic or basaltic, you get intermediate or andesitic, and you get felsic or rhyolitic. So mafic igneous rocks melt around 1100 to 1250. Your mafic basaltic rocks melt around 950 or 1100. Your intermediate andesitic rocks, they melt around 800, 950 Celsius. And your felsic rhyolitic melt around 650 to 800. So now let's talk about something else that magma possesses, or a property that magma has, and that is viscosity. Viscosity is the resistance to flow. So how much a material resists flowing, that property is called viscosity, and magma has it. So imagine if you have a magma that is very, very molten, it will flow quickly and it's not very viscous. But if you have a magma that is not very hot, it will not flow very quickly. So viscosity is the resistance to flow. So what determines viscosity in magma? So what determines viscosity in a magma is the percentage of sulfur dioxide. Higher SiO2 or sulfur dioxide content magmas have higher viscosity than lower SiO2 content magmas. So if you have a high percentage of SiO2 or if you have a high percentage of sulfur dioxide in the magma, you get higher viscosity than those magmas that contain lower SiO2. Also, lower temperature magmas have higher viscosity than higher temperature magmas, and this is very, very intuitive. Imagine having a cake mix, and the cake mix is not very hot. If you try to pour the cake mix, it will not flow fast. But if the cake mix is very, very hot, it will flow fast. So lower temperature magmas have higher viscosity, and higher temperature magmas have lower viscosities. So how do magmas become rock? Well, they become rock through crystallization. You know that any material, when you give it heat, the particles in the material, they get excited and they jump around. If you give it enough heat, the bonds that exist between the atoms will break, and you get a material that will turn from a solid to a liquid, and from a liquid to a vapor, and all the atoms will get away from each other. Crystallization is the exact opposite of this process. When you have energy taken away from atoms, the atoms will actually pack and will turn from a gaseous state to a liquid state, and from a liquid state to a solid state. So magma is in a liquid state, and when it cools, or when it loses all its heat and energy, the ions and the atoms will pack and create crystals. And with this we come to the end of our lecture. So to recap the whole lecture,